Let us look at yet another example to illustrate the concept of field of view. So here is shown a mirror with this as its reflecting surface. This is an observer that is looking into the mirror. Now here is a biker who is riding the bike, and the biker is going to be moving in this particular direction or this particular sense. We have been asked for how much time can this observer observe this biker in the mirror. So basically, for how much time will the biker be in the field of view of this particular observer? This has been asked. Certain parameters are given. The line along which the biker is moving, this particular line along which the biker is moving, this line is at a distance of 2d from the mirror, and the observer is at a distance of d. So this is d and this is d. This is given to us. Now let us see how the rays of light will behave. Okay, so as we know, in questions or in examples wherein field of view is important, we have to draw the edge point rays basically, or the end point rays vis-a-vis with respect to the mirror. So this is one such ray, and another ray is like so. Alright, there is something called as a principle of reversibility of light. Okay, this principle of reversibility of light says that if, let us say, this ray comes and strikes the mirror and enters the eye of the observer, then if I start drawing a ray from the eye of the observer, then it will strike the mirror and go back along this path. So this is one implication of the principle of reversibility of light. So actually speaking, we would like to analyze this particular ray that came like this and then went into the eye of the observer. But I started drawing the ray from the eye of the observer and went thus forth. Alright. So if I were to have a sense of how the light is actually being directed, it is being directed so. Alright. Now we need to understand that if the height of the mirror here in this example is given to be L, height or length of the mirror. So this has been given to be L. So if this is L, it is very clear and apparent for us to understand that this distance has to be 2L. This particular distance has to be 2L. The reason for that is simply this. I'll construct a dotted line over here. So if this is X and this is Y, I'll construct a dotted line over here like so. Okay, it will not be 2L, it will be more than 2L. If this is X and this is Y, then we know that this particular angles are congruent. So if this is I, this is R. Now if this is X, that means this is X and this is Y. Alright. Also, this much is D and this much is D again. Okay. So this is X, so this happens to be X because of congruency of triangles, and this here will be 2X, and similarly this here will be 2Y because of congruency of triangles. So this is Y right over here, this is also Y, and then if we equate tan thetas, so let us say this angle over here is theta, then tan theta happens to be equal to y divided by d, and tan theta also happens to be equal to 2y divided by 2d, or if you don't know this length, then let's call it p. Then tan theta happens to be equal to y divided by d, and it happens to be equal to p divided by 2d. Therefore p is equal to 2y. Similarly, this, if let us say this is q, similarly we can find out that q is equal to 2x. So this total length is going to be 3x plus 3y. That means if the length of the mirror is L, then this total length, this particular total length is going to be 3L, simply speaking. So L is equal to x plus y, and the length of the path of the biker that lies within the field of view of this observer happens to be 3x plus 3y. Okay, so length of path happens to be 3x plus 3y is equal to L. Alright. Furthermore, it is stated that this biker is moving with the speed of u. Okay, so we have been asked the time for which the biker will stay in the field of view. So the time simply becomes t is equal to length of path divided by u, the velocity, the constant velocity of the biker. Therefore, t happens to be equal to 3L. This is 3L. So 3L divided by u, wherein L is the length of the mirror. And the biker will start over here, enter the field of view, stay in the field of view for a time equal to 3L upon u, and then exit the field of view. So for this particular length of time wherein the biker is present over here, our observer, when the biker is present in this particular region, our observer is going to be able to see the biker. Alright.